Alrighty, team. So practice 1 is asking us a question about y equals 1 plus 3 sine of 2x. So when I go to graph any trig function, kind of one of the first things that we want to do is identify the midline. So the midline here comes from our k value, which is plus 1. We'll also want to identify our phase shift. Remember, your phase shift is the h value, the number that is subtracted from x. We notice here in practice 1 that that would be 0, okay? We want to figure out then whether or not our curve starts on the midline or a maximum or a minimum. Since it's a sine function, I know that we're going to start on the midline. So the first point of our cycle is going to be there at 0, 1. We'll then use the period to figure out how long does this cycle have along the x-axis, right? How much horizontal distance does the cycle of our sine curve have? So, or how long does it last, right? So our period for a sine or cosine function is found by taking 2 pi divided by b. You'll notice here that b is 2, so our period is pi. That means that at pi units later, we have to return to the midline, right? We end our sine cycle. We saw in our notes from last week that we need to divide the period into fourths in order to place all of those points from our sine cycle. So those points that I'm talking about, those 5 key points from our sine cycle, they, with no transformations, are the midpoint, or the midline maximum, midline minimum, midline. Okay, so we need to fit this cycle between 0 and pi. We need to use our amplitude, though, to figure out, first off, if we're going to a maximum or a minimum first, and how far those will be off of our midline. So our amplitude is 3. Noteworthy is the fact that it's greater than 0, right? So an a value of greater than 0 says we need to go from our midline up to our maximum, okay? And that happens at that next kind of quarter of our period. So our amplitude is 3, which means a quarter of the way through our period, we're up at our maximum. Halfway through our period, we're back at the midline. 3/4 of the way through the period, we're down 1, 2, 3 units. Again, that distance, that amplitude off of the midline. And then we end that cycle at the midline again. So we've just drawn the points of one cycle of this function, okay? Pausing, I notice I'm asked for a maximum point of this graph. So a maximum point of this graph is going to be occurring here at the highest possible point that my function can achieve. When I look at this point, I see that it is halfway between 0 and pi over 2. So if we think about that kind of maybe in terms of our unit circle or just how fractions work, we know that this is the point pi over 4, comma 4. I can look at my answer choices and see pretty quickly that that's not one of them. I can also see that my answer choices, some of them include a 3 as a y value. Well, those aren't going to work because my maximum value is up at pi. Up at 4. But the x value is pi over 4. I don't have the point pi over 4, comma 4. Remember in class I did say that there's no guarantee that these characteristics are going to exist within one cycle of your function. So what this means is we need to continue, right, building our function. So we know that we'll have another cycle existing between pi and 2 pi. We'll need to split that up into fourths to help us see where all those other points, all those 5 key points of this next cycle fall. So we start at our midline, jump to our max, back to our midline, down to our minimum, to our midline. So we see a second cycle here. Do our best to connect those points. What that introduces is another maximum point. That maximum point has a y value in between pi and 3 pi over 2. Thinking to my unit circle, I can easily identify that as 5 pi over 4, comma 4, which is answer choice D for me. Okay, so 5 pi over 4, comma 4 is our answer to practice 1. Practice 2 asks us for a 0 or an x-intercept of the graph of y equals tangent of x. So y equals tangent of x I know is kind of new for us. We'll still kind of follow that same similar type process, right? Identify our midline. It is 0. There is no number added or subtracted outside of our trig term. we'll identify our phase shift, that is also 0. So in tangent, what's nice is that we have just identified our midpoint. Our midpoint is sitting here at 0, 0. We then need to determine the period of this function. So remember that tangent has a period of pi over b. In this case, b is 1. So our period is pi. We need to split that over the midpoint. So we need a total distance of pi units to exist between our vertical asymptotes. So we'll have a vertical asymptote at negative pi over 2 and positive pi over 2. We can repeat that to build a vertical asymptote at negative 3 pi over 2 and positive 3 pi over 2 as well, which is maybe unnecessary information if I'm after just an x-intercept, okay? So I already have an x-intercept, right, 0, 0, but that's not an answer choice. So what that's doing is it's forcing us to build more cycles of this function. But I should probably finish this first cycle that we have. We'll build our quarter points, right? We use our amplitude, making sure to consider any reflection to plot the quarter points. Our amplitude, our a value is 1, which means that when we step to the right, halfway between our midpoint and our quarter point, we should be up above the amplitude, a unit of 1. When we step between our midpoint and our vertical asymptote on the other side, our amplitude, we should be down at negative 1. So this is one complete cycle of our tangent function, and we can copy and paste this over here and over here. So that means a midpoint has to exist between all of my vertical asymptotes, meaning there will be a midpoint at negative pi comma 0 and pi comma 0. And that's actually enough to identify our answer, right? If we look really quickly, we have 1, 2, 3 x-intercepts, one at negative pi comma 0, another at 0, 0, another at pi comma 0. So we can determine our answer to be the point negative pi comma 0. Practice 3 kind of packs a little bit of a punch. Not only is it cosine, which is a little harder to transform, but it's not in transformation notation. So that kind of comes up as an issue in like the later steps of graphing and not so much initially at the top, at the start of this, right? Identifying our k value is pretty straightforward. It's the number added or subtracted to our trig term. So our midline is at y equals negative 1. The form that this is in becomes problematic when we go to find our h value. H is the value that is added or subtracted from x. Notice pi is being added to 2x. Okay, this does not fit my definition for phase shift. So I need to manipulate the argument of cosine to fit this form. What that means is I need to manipulate to just see x plus a number rather than 2x plus a number. So I need to undistribute that factor of 2 from both of these terms. Doing that gives me the equation y equals negative cosine of 2, right? 2 doesn't disappear. We still need that. We're just trying to reorganize this form of x plus pi over 2, close our parentheses, minus 1. You can always check yourself. Distribute back in. 2 times x gives us 2x. 2 times pi over 2 gives us pi, right? We haven't changed our function. We've just allowed ourselves to identify that the h value, the number that is subtracted from x, is negative pi over 2. So that what that means, right, this is a little bit tricky with cosine because that doesn't necessarily give us our starting point right away. It tells us, though, that along our midline, our period, that first cycle of our curve is going to start at negative pi over 2. Right, it's going to start somewhere along this x value. We'll talk about where here in a moment. So we know where the cycle of cosine is going to start. We need to figure out where the cosine of cycle is going to, the cycle of cosine is going to end. That comes from taking our period and calculating our period, which is 2 pi over b, which we know is 2. So we know that pi units later, the cycle of cosine is going to have to end. Okay, so negative pi over 2, another pi over 2, right? So we have 2 pi over 2's, which simplifies to pi. So we know that one cycle of a cosine curve of this nature is going to have to fit between negative pi over 2 and positive pi over 2. Without any reflections or transformations, our cosine cycle is max, mid, min, mid, max. So this would be a positive cosine of x. We have to pay special attention to the fact that this is actually a negative cosine of x. So if I wanted to plot a negative cosine of x, we're going to have to vertically reflect all of these points, and we'll see that the cycle that needs to fit between negative pi over 2 and positive pi over 2 is actually minimum, midline, maximum, midline, minimum. So using all this information and the fact that A is negative 1, we know that the starting point of our cycle is 1 below the midline. So 1 below the midline, we will start and end our cycle at that value. I know that halfway between that, just kind of using the symmetry of my cosine cycle, I know that halfway between negative pi over 2 and pi over 2, I'll have to be at my maximum. And halfway between my max and my minimum, I'll have to be at my midline on either side. So we've just graphed one cycle of this function. And I'll look at my directions. My question is asking, what is a minimum point of this graph? So I see the minimum value will be negative 2. That allows me to disregard any point with a different negative value. And I can see that we actually do hit, right, these 2 points that hold that minimum value. We have negative pi over 2, comma, negative 2, and we have positive pi over 2, comma, negative 2. So we see our answer, pi over 2, comma, negative 2. Okay, you can see that if you were to repeat this cycle over and over again, pi is actually going to hold a maximum point, and that negative pi over 4 actually holds a midline point. So practice 4 is similar in kind of the trickiness up front, right? Now we're looking at tangents, so that's a little bit different. So those of you who are kind of not super comfortable with tangent yet, this would be a good thing to kind of tune into. But similar to the last problem, we don't have the transformation form, right? We don't have x minus pi over 2. We actually have 2 times x minus pi over 2. So when we get to identifying the phase shift, we're going to have to deal with that. But I'll kind of stay consistent with the processes that we've dealt with so far, identifying our midline or our k value. So our k value, our midline is 0. Our phase shift, again, that is our h value. So what is the number? I guess I should say, before I said added or subtracted, but I really want us to get comfortable with the fact that it's the number subtracted from x. So we need to manipulate this, much like we did before, to show ourselves what is the numerical value that is subtracted from x, not the numerical value that is subtracted from 2x. So that means we undistribute a 2 within that argument of tangent. We're left behind with x minus pi over 4. Pause and think about that if we need to. Okay. What that tells us is that our h value is equal to pi over 4. Notice it's a positive shift because we are subtracting pi over 4. The number that is subtracted is positive pi over 4. So this means our midpoint, right? Remember from our notes that tangent, that midpoint is h comma k. So h is pi over 4. K is 0. And maybe it's worth looking at, okay, well, what am I after? Here I'm after my vertical asymptote, so I should keep building this out, right? I'm going to have to identify the period. Recall that the period of tangent is pi over b, so that would be pi over 2. We have to split the distance of pi over 2 over the midpoint. So a vertical asymptote will lie pi over 4 units below the midpoint and pi over 4 units above the midpoint, so that we have a distance of pi over 2 between the 2 vertical asymptotes. So just by kind of sketching not even a full cycle of this function, I can start seeing that I'm going to have a vertical asymptote at x equals 0 and x equals pi over 2, but that's not an answer choice, okay? Just for fun, I want to finish this cycle noticing that my a value is -2. So when we step to the right, when we go to our quarter point, the point that is somewhere between our midpoint and our first vertical asymptote, we're actually going to be stretched all the way down here at -2. And then on the other side, we'll be up at +2. Okay, so we have that vertical reflection where that positive side of tangent is actually reflected down and stretched away by 2 units. That negative side of tangent has now been flipped up and stretched away by 2 units. Not necessary for us to answer this question because we could continue just to build out the vertical asymptotes, right? We know that there will be vertical asymptotes every pi over 2 units, okay? Because we have to build this symmetry throughout our curve, throughout the repetition of the cycle of this function. So we have vertical asymptote at 0 we already identified, and at -pi over 2. It looks like -pi is also an answer choice, or -pi is also an answer, but not an answer choice, but pi is. So we have 3 answers for practice 4. All right, practice 5, which of the following is a vertical asymptote of this graph? So very similar question from before, maybe a little bit different in kind of the mechanisms of graphing it, just based upon the fact that k is equal to 0, so our midline is 0. H is equal to 0, so our midpoint is 0, 0. Our b value is 2, so the period that must split our midpoint is pi over 2. So at negative pi over 4 and at positive pi over 4, I will have vertical asymptotes so that there is a period or a distance of pi over 2 between those 2 vertical asymptotes. Okay? So right away, I can identify one of my answers. A vertical asymptote certainly exists at negative pi over 4. Pi over 2 units later, in the positive direction, I'll have another vertical asymptote. So I can see that another vertical asymptote exists at 3 pi over 4. It looks like pi over 2 will not cut it, and pi will also not be a vertical asymptote, right? That's actually where more midpoints would exist. Okay, so that's just coming from copying and pasting, repeating this cycle over and over again. If you're curious, the full cycle, oh, I can't even fit it because of my scale on my y-axis, but let's say I changed the scale on my y-axis. We'll just count up by 1s. So because the amplitude in this equation is 3, we would have a point at 1, 2, 3. Our quarter points, sorry, I should use the vocabulary that we've been discussing. Our quarter points will be plotted between 0 and pi over 4, so at pi over 8, comma 3, at negative pi over 8, comma negative 3. And again, we'll just repeat that pattern within each of these periods. Oops. And I should include another vertical asymptote here. It looks like we have one more midpoint that will fit. I think you could probably sneak in one more quarter point here, definitely one here, and we'll actually be able to graph nearly 1, 2, almost 4 full cycles of this function. Okay, but I would argue that's overkill, right? We were able to identify those vertical asymptotes pretty quickly. Practice 6 is asking for a maximum point of this graph. Going back to sine, that's kind of a friendly one because our starting point, right, the first point of the cycle of sine actually sits on the midline. So it's a little bit more straightforward to identify than the starting point of cosine. But following those notes that we've been kind of relying on, we want to plot our midline. K equals 0. We will want to identify our phase shift, which is h equals pi. So that tells us, because of that, the nature of sine, that we start midline, max, midline, min, midline, that tells us at the very first point of our sine cycle, it's going to be at pi comma 0. So pi comma 0 sitting right there. We'll then want to figure out how long is this cycle going to last. So what is the period? So 2 pi over 1, because our b value is 1. Our period is 2 pi. That means that 2 pi units later, our cycle ends. So we're splitting up our period then into fourths so that we know where we hit the midline again and where we'll hit a minimum or maximum depending upon our amplitude. So peeking back at our equation, we see that our amplitude is 4. Because that is greater than 0, we're going to go from our first point that is on our midline up to a maximum that is 4 units off of the midline. We will then drop to our midline, down, so then go to our midline, down to our minimum that is 4 units below the midline, and then back to your midline. So this gives us one cycle of this function. Maybe pause and see, okay, we're trying to find a maximum point, so it's going to be occurring at 4. Unfortunately, we can't get rid of any of these answers. I do see that between pi and 2 pi, there's a point at 4. Okay, so thinking back to my unit circle, the angle that is between pi and 2 pi is 3 pi over 2 comma 4, so we can select that first one. We will want to kind of, again, copy and paste this, right? So repeat this cycle. So pi units to the left, we will have started another cycle. We'll have to hit the midline in between. We'll have to hit the maximum point and the minimum point as well, right? So all I'm doing is I'm repeating that cycle, but off to the left-hand side. There should be perfect symmetry there. We see that between 0 and pi, there's another maximum point. So thinking to my unit circle, the angle between 0 and pi, I should be more careful. The angle between 0 and negative pi is negative pi over 2, and that has an y value of 4. So we have negative pi over 2 as well. It's safe to say that pi over 2 is not an answer, but we may want to investigate what's happening at negative 3 pi over 2. So at negative 3 pi over 2, we know negative 3 pi over 2 is between negative pi and negative 2 pi. If we were to continue this pattern, we'll see pretty quickly that negative 3 pi over 2 is actually going to hold a minimum value. So we have our 2 answer choices there. Last one that I'll go over in this video. Oh no, I lied. 2 more to go over, so sorry. Finding the period of this equation, we, again, period for tangent. Is pi over b. B is not immediately obvious in this form. Maybe for some of you it is, but I don't think it would hurt any of us to rewrite it in transformation form where we can reorganize this as a statement of x minus a quantity. Notice that if we take 1/2 out from the x and the pi, we'll be able to quickly identify that our b value is 1/2. Check yourself if you want to. 1/2 times x gives you x minus 2. 1/2 times negative pi gives you negative pi over 2. So to find our period, we need to, for this tangent value, take pi, divide it by 1/2. Remind ourselves that this is just pi times 2 over 1, or 2 pi. Last one, which graph models 4 times sine of x minus 4 plus 4? So one thing that I noticed right off the bat is I'm going to have a midline of 4. So I might just kind of sketch that out and make sure that that is true excuse me, for my curves. So unfortunately, that doesn't eliminate any of them, okay? What is helpful, though, is that we have this phase shift of pi. So we have h equals pi. What this means is we have to move the first point of our sine cycle right pi units. it's already been moved up 4 units because of k. I want to move it right pi units. Okay, so again, what I'm looking for is this behavior, midline, maximum, midline, minimum, midline. I want that behavior starting pi units to the right. So in my first one, if I go pi units to the right, I do not match this behavior, right? I go actually down to a minimum. So this would be a negative sign function. We do not have a negative sign function, so we can eliminate that. In the second problem, the second graph, if I go from 4 on my midline over to pi, I see that my point is a maximum. That means that this is a cosine curve, so that is out. Looking at answer choice C, if I go over to pi, my point is at a minimum. This would actually be a negative cosine graph, so that is out. Process of elimination does tell us that it's going to be D, but it would be worth noting that if we shift over to pi, we do follow max and midline next. So we start our cycle of maximum, midline. That is that move that we were looking for, that initial cycle of our sine curve. So answer for practice 8 is D. I will post some sort of an answer key for the matching cards, but I do not have them in a movable form to include in this video. So if you're interested in an answer key for the matching graphs and equations, maybe check the week at a glance. Not maybe, it'll be there. It'll be at the week at a glance. If anything was confusing or unclear through this video and you have any questions, please send me an email. Otherwise, good luck on your check-in tomorrow. You will crush it. You can do difficult things, and you've learned so much math this year. All right, thanks.